Hey there, Joel here and welcome to my channel Math World. Today is part 2 video of proving trigonometric identities, and the question is cos A upon 1 minus tan A minus sine square A upon cos A minus sine A is equal to cos A plus sine A. And I'm sure every time you read these questions, they look so complicated that you feel like forget it, I don't even want to try solving them. And I'm sure that is what is happening in your mind as well when you're looking at this question, and I'm purposely keeping it for a while so that it sinks into your head. Now again, first step, when you're solving it, choose the side that you want to solve. So I would prefer, most of the Goa board questions that are asked, it's usually the left hand side that you have to solve. I'm not saying it is always that way. Most of the times there can be an exception, so consider that most of the times we solve the left hand side. So I have written left hand side is equal to, once again here, now I will try to take some action on this problem. So what I will do is, I have changed this tan A and written it as sine A upon cos A. Okay, now you will ask me or you can comment in the video that every time I see tan A, shall I convert that as sine upon cos? It is not compulsory. What you are looking at this problem on this page is the final attempt of solving that entire problem. What you are not looking at is all the other rough work, rough practice problems that I have done to get to this answer. So it is not directly that you come up to this conclusion, but it's more of practicing the problems so that you can understand how to solve it. So technically, whenever you see tan A, you cannot directly always change it to sine upon cos. Here in this case, it is working out that way. So what I've done is, I have changed tan A as sine upon cos A. Okay, rest everything is written as it is. Next, what I will ask you is, slightly deviating from this part, if I have a number, say 1 minus 2 upon 3, how will I write it with 1 as one fraction? I have two fractions, right? So this is also upon 1 as such. So 1 upon 1 minus 2 upon 3. Now if I want to write it under one fraction, all I will do is, remember this, take this 3, multiply over here and write everything as it is. Simple as that. Take the denominator and multiply to the number which does not have a denominator and write everything as it is. So this would become 3 ones is 3 minus 2 upon 3. Okay, so rest everything is written as it is. So this would become 3 minus 2 is 1 upon 3. So this entire problem, after solving, what you will get is 1 upon 3. Simple as that. Okay, now instead of 1 minus 2 upon 3, what you have is 1 minus sine upon cos. So that will become, okay, just don't look at this. I'm sure there's a doubt in your head now, how come this became square where it is only cos over here? So I'll clear that as well. But here what is happening is, this would become 1 minus sine A upon cos A, right? So I told you, take the denominator, multiply to the number which does not have a denominator and write everything as it is. So this will become cos A minus sine A upon cos A. Alright, so I have something like this now. Where it will come? It will come over here, and then this cos A will be over here, which I have not written. Now why I have not written is because, please ignore that sound here, come on. I don't know why every time when I'm recording a video there has to be one vehicle which has to pass this side with a very loud noise. Okay, so here what will happen is, if you remember your I guess 4th or 5th standard portion, 1 upon 2 divided by 3 upon 4. This division could be changed into multiplication by writing 1 upon 2. I hope you can see this. 1 upon 2. Changing this division into multiplication, this will be reciprocated. So 4 upon 3. I hope you remember this part. This was probably in the 5th standard or 4th standard you have studied. So changing the division sign into multiplication. So the denominator automatically reached in the numerator. And that is what happens over here. This cos A, which is in the denominator over here, okay, in this place actually, will go and multiply in the numerator. There's already a cos over here, cos A, and this cos A, when you multiply, that's how you get over here cos square A, and rest everything is as it is. Now if you look at the denominator, now I have cos A minus sin A, and I have cos A minus sin A. In the previous video that you have seen, we have realized that whenever you have a same denominator, you can write it once. So I've written that. And look over here, there is cos square A minus sin square A. Is it reminding you of any algebraic identity? I'm sure it should. So keeping that in mind, write it over here. What is the answer for A square minus B square? My A over right now in this question is cos A and B is sin A. So think about it and write it over here. What is the answer? And once you get that, I'll put a bracket so that it becomes easy, because from here A square minus B square are two brackets that you will get. Which are they? You need to tell me. Okay, so once you get it, you should be able to get the answer, which will be this. Okay, that's, I'm not completing it. I want you to practice and attempt this problem. Alright, and again, if you like this video, please don't forget to hit the like button, share the video with your friends, subscribe to the channel, and stay blessed. Keep on practicing these identities so that you can become better at them. But wait a second, how will you practice if I don't give homework? And here you go, you have 2 problems to attempt, and if you want more, you can use your textbook for exercise 8.4, and there are so many problems over there for practice. Try them. And one point of caution I will give you is that, ignore the sound. Okay, one point of caution is that whenever you're solving these identities, initially when you try solving those problems where you have a solution. That means you know how to solve that entire problem is solved somewhere on the book. You are going to attempt it without looking. You're going to try solving it that way, but you already have the entire answer with you, because in that way you will be able to check whatever you are doing was right or wrong. Because otherwise, if you're solving a question where you don't have an answer at all to it, then that will be a problem to verify and check. But why are you worried when I'm there? You can always click a picture and email it to me. I have my email ID in the description box. Alright, so I can help you, but initially start solving problems which are already solved and you just practice them without looking. I'm not telling you copy them, practice. Okay, and you should be able to solve these identities better. And for all those students who have found these last 3 videos completely irritating and boring, and don't want to solve them at all, it's fine. Trust me, it's okay. Don't hate trigonometry because of these 2-mark questions. Alright, so don't do that. If you don't want to solve this 2-mark question, it's okay. You're going to answer an 80 marks paper, and in that 80 marks paper, if you are going to leave 2-mark question, that means you're going to answer your entire paper of 78 marks. But if you spend some time instead of these problems which you don't like and learning something different, then that's fantastic. It's okay. Okay, you don't have to attempt every question to get full marks. You can attempt certain questions and be sure of what you're scoring. So spend time in practicing those problems which you like doing, and you should not make mistakes in solving those. If you prefer leaving this 2 marks, it's okay. But in case you plan on taking science in 11th and 12th standard, then you have to attempt it, because these kind of questions will be there in 11th and 12th. All right, so take care and bye bye.